First thing we need to talk about when we're solving equations by graphing is all of the names that you're going to have for the x-intercepts. Now, we've typically just asked you for an x-intercept. And whenever we ask that, we're looking whatever the x number is, and 0, because that's where y is 0. Now, we're going to add a couple new names for the exact same points on your graph. The first one is called a root. Now, you'll be given the roots of an equation, usually just like a list of numbers. That's a horrible squiggly bracket. All right, another name that you're going to have is a solution. And this one's also just a list of numbers. Now, the last name you're going to need to recognize is called a zero. And I think they got really creative with this name because it's where y is 0. Now, whenever you're talking about solutions of equations, we have a lot of situations. So the number of solutions can go like this. Okay. If your graph hits twice, then you have 2 solutions. Another option is to have your vertex hit right on the x-axis. Now, whenever you do that, you only have one solution because it only hits the x-axis one time. We call this a double root. And the last possibility is if you've got a parabola floating in the middle of nowhere. Now, this has no real solution. Now, it does have an imaginary solution, but we're going to get to that in another video. Let's go ahead and look at the first equation. If I want to graph x squared minus 4, so I have a graphing calculator over here, and all I need to do is just type in my equation, x squared minus 4, and you hit enter. Beautiful graph. Now, this particular graph is pretty easy to find the solutions for because they hit exactly on coordinates. You're going to have a solution of x equals 2, and over here x equals negative 2. Now, if you'd solved x squared minus 4, you'll notice that the factors are here are x equals plus or minus 2. Now, the next equation, we've got x squared minus 4x plus 4. Now, I already graphed this one. If we want to take a look at the solutions here, you'll notice that it only hits in one spot, right there. So this means we have a single root at x equals 2. Let's go ahead and take a look at number 3. We have a negative x squared minus 4x plus 32 equals 0. Now, I've already entered the equation into your graphing calculator. So when we hit enter, we get this huge parabola with a y-intercept of 32. So we need to go ahead and change the window in order to see what the whole parabola looks like. So using this calculator, you just hit menu, and you're going to window zoom. And I like to use zoom fit because the Nspires automatically grab whatever you want to look for and fit it into your screen. Now, when we're looking at this parabola, it hits almost perfectly, but not quite. So we're going to use another function. We're going to go into menu, and here we have a function that says analyze graph. Now, if you do that, one of the things that it's going to find for you is a 0, which you'll remember is another word for our solution. Now, the first thing it asks you for is a lower bound, and so you're going to use your finger and your touchpad enter somewhere on the left of the screen. Then you're going to do it again on the right of the 0, and it'll give you an answer. Now, if you do it again, you can go find the other 0. And as you can see, the zeros for this equation aren't perfect, but they were darn close. So if I wanted to write my answer for this, I would have x equals, and 2 decimal places works, so we have a negative 6.18 and a 5.18. All right, the last example. When we use a negative x squared plus 4x minus 6, we should have a parabola that's upside down. And I went ahead and graphed this one as well. Now when you're looking for the solution or the root here, you're going to look for where it touches the x-axis. Now this one doesn't touch anywhere, so your answer is going to be no real solution. Now graphing quadratic functions in order to get solutions is a great way to do it if you have a graphing calculator, and you don't really need perfect answers when you're solving for decimals. All right, that's how you solve by graphing. Hope this helped.